we have a surprisingly limited view of what's below it. It's the last unknown place on Earth.
In this video, we take you on a journey into the heart of the American heartland, Kansas. Beneath its rolling wheat fields, amber prairies, and quiet towns, a secret as old as time itself is hidden in stone. What if we told you that long before the first human ever set foot on these plains, before bison, before mammoths, Kansas lay submerged beneath a vast, ancient ocean? And what if recent discoveries aren't just whispers from the deep past, but compelling evidence, a remarkable fossilized record captured forever in limestone and chalk, showing that a sea, hundreds of feet deep, once covered the landlocked soils of today's Midwest? Forget the image of Kansas as endless farmland and tornado alleys. Picture instead a world where strange marine life flourished, where the sun filtered down through blue-green waters, and the only sounds were gentle currents and the movements of prehistoric creatures. Carcasses settled onto a muddy seafloor, their bones destined to fossilize and wait tens of millions of years to be found by humankind. This isn't fantasy, it's the evidence scientists have been unearthing, layers of proof that invite us to rethink everything we know about North America's past. So, how did Kansas, the very center of the continent, become the graveyard of a vanished sea? How do we know this is more than just a hypothesis, more than speculation? And what did scientists uncover that left geologists across the world amazed? Let's plunge into the buried ocean of Kansas, uncover fossils and rocks that rewrite history, and ask, what other secrets might still be hiding under our feet? The cemetery beneath the prairie. It begins as a whisper, a rumor passed from one rockhound to another. Fossils, crinoids, ammonites, mosasaurs turn up across Kansas in limestone cliffs, road cuts, and even plowed fields. Chalky white bones twisted into fantastic shapes, shells pressed into stone, teeth the size of switchblades buried in ancient shale. When paleontologists first surveyed these findings, one question surged to the surface. How could the remains of marine creatures appear so far from any shore? To understand, you have to look at the land not as it is now, but as it was more than 80 million years ago. During the late Cretaceous period, when dinosaurs ruled the continents and flowering plants spread across Earth, Kansas sat at the bottom of a shallow, teeming sea. This was the Western Interior Seaway, a primeval ocean stretching close to 2,000 miles long and 600 miles wide, cutting clear across North America from the Arctic in the north to the Gulf of Mexico in the south. The numbers are staggering. At its largest, the seaway was over 2,000 feet deep in some places, though in Kansas it was generally a few hundred feet deep, deep enough to submerge any city skyscraper. Kansas, right at its heart, was entirely covered by water. An ocean reached from Texas to Montana and eastward toward what we now know as the Appalachians. An expanse of brackish, life-filled waves rolling over land that today grows corn, wheat, and soybeans. How do we know? The proof lies in the very bedrock beneath our feet. Each slab of limestone, each band of chalk, is a page in the Earth's diary. Layer by layer, they tell the story of ancient saltwater, of sediment dropped by tides, and seashells fossilized over the millennia. Today, the abundance of one of Kansas's most common fossils, a flower-shaped animal called a crinoid, is a clear signal of this marine world. Known as sea lilies, crinoids anchored themselves to the ocean floor. Hundreds of millions of their stalks, arms, and skeletons blanketed the seabed, leaving behind calcium-rich fossils that, after the seas receded, became scattered across the land. But where, in what seems now only endless prairie grass, do you find a window into this sunken past? The Great Fossil hunt. Across western Kansas, a slow but relentless hunt is underway, one that has attracted scientists, fossil collectors, and amateur sleuths from all over the world. They explore cliffs of ancient chalk near towns with names like Castle Rock, Monument Rocks, and Niobrara. Here, the rock is soft, pale, and layered, a perfect medium for capturing traces of life in stone. Each strike of the pickaxe can reveal something remarkable: the ghostly outline of a fish, its scales still shimmering after 80 million years. A seashell as delicate as porcelain, the articulated skeleton of a marine reptile. Some finds are truly astonishing in their scale: the fossilized remains of the mighty mosasaur, a 40-foot crocodile-like predator that once made the western interior seaway its hunting ground. And then there are the crinoids by the thousands, tiny, ringed discs that once formed the stalks of these living filter feeders, now scattered like currency on a long-lost seafloor. Missouri, Kansas's neighbor to the east, is well known for crinoids, providing more evidence that the reach of this primordial sea was immense. For paleontologists, it's not just the quantity of fossils, but their diversity and their extraordinary state of preservation that tells the real story. Scientists estimate they have found fossilized evidence of less than 1% of all the species that have ever lived. For every crinoid or ammonite unearthed, thousands more are lost to time, washed away, dissolved, or crushed beneath the relentless pressure of sediment. Yet the sedimentary layers in Kansas are notably rich, an ancient burial ground preserving the remains of complex ecosystems as strange as those of today. Recently, researchers have found Kansas fossils so well preserved that even impressions of skin and the outlines of eyes are sometimes visible. Such remarkable finds push the boundaries of what we know, helping form a direct and tangible connection to an ancient ocean that was indeed a crucible of life. What makes these discoveries even more extraordinary? The realization that, locked inside the rocks beneath Kansas, lies a library of Earth's prehistory, waiting to be read. A sea of monsters, life in the Western Interior Seaway. The Western Interior Seaway was no gentle pond. This was an alien ocean, filled with creatures both beautiful and bizarre. Picture currents of jellyfish drifting among razor-toothed predators. Crinoids swayed like underwater gardens on the seafloor, drawing nutrients from passing currents. Giant turtles, some as large as cars, rose to the surface for air before vanishing again into the depths. Ammonites, coiled like snail shells, but sometimes as big as a beach ball, drifted by the millions. And then, the kings of Kansas's sea, the mosasaurs, reigned supreme. These were not fish, but giant marine reptiles, muscular, paddle-limbed, with long tails and jaws lined with sharp teeth. One fossil found in Kansas revealed a mosasaur with another, smaller marine reptile inside its belly, a meal frozen in time. Sharks, too, prowled these waters, not the same species as today, but their ancient kin. Some bore saw-like jaws, others had crushing teeth for breaking shells. Fossilized shark teeth, black, glossy, and perfectly preserved, dot the strata, sometimes in point, clusters that bear witness to feeding events from an age when Kansas was an ocean. Occasionally, paleontologists have discovered fish fossils so exceptionally preserved that their stomachs still contain the remains of their last meal, an astonishing snapshot of prehistoric life, capturing a moment ended suddenly, millions of years ago. But perhaps nothing stirs the imagination so much as the rare discovery of fossilized embryos, such as those found in far-off South Africa. These tiny, well-preserved beginnings are a powerful reminder that the fossil record is an interconnected chronicle stretching across continents, proof that Earth's ancient seas were teeming with life at a global scale. How could so many marine forms thrive far from modern coastlines? Because the Western Interior Seaway was an ecosystem as bustling and diverse as any modern ocean, and the fossils left behind are the evidence. The proof locked in stone, limestone, chalk, and fossils. But fossils are only part of the story. Perhaps the most striking proof that an ocean hundreds of feet deep once covered Kansas lies within the rocks themselves. Walk any rocky outcrop in western Kansas, and you're treading atop what was once an ancient seabed. The region's famous chalk beds are among the world's thickest, built up layer upon layer, sometimes hundreds of feet deep. Made from countless microscopic shells of plankton and algae, chalk forms only in deep, calm, and warm marine environments. The sheer depth and purity of these deposits is only possible if Kansas spent millions of years underwater. Limestone is another clue. This sedimentary rock, packed with the skeletal remains of marine creatures, preserves the chemistry of ancient seawater. In certain bands, you can see with the naked eye crinoid stems, coiled shells, and fossilized sponges preserved seemingly in place. Each fossil becomes a chapter, recording the salinity, temperature, and changing depth of the long-vanished sea. Core samples drilled deep into the earth in Kansas reveal marine clay, sediment that forms only in oxygen-deficient, relatively deep water, far from shore. These silts, filled with remains of ancient plankton and mollusks, give geologists a timeline. Layer by layer, scientists reconstruct the rise and eventual fall of the ancient seaway, and there is no shortage of material to study. Across the Midwest, from Texas to South Dakota, the rocks repeat the same tale. Marine sediments hundreds of feet thick, undisturbed, perfectly layered, and filled with the fossil remains of the prehistoric sea. To this day, Kansas farmers plowing their fields sometimes unearth bones, a mosasaur's jaw, a turtle's shell, a crinoid fossil. Road crews slicing through limestone occasionally expose beds so rich in shells and ancient remains that they seem like paved streets of a forgotten world. But perhaps the greatest triumph of geological research is the direct evidence. Layer after layer of undisturbed rock, holding signatures of ancient tides, undisturbed for millions upon millions of years. What does it feel like to stand in the heart of Kansas, to touch a slab of chalk, and to know you are laying a hand on the floor of an ocean that disappeared before humans ever existed? Geological detectives: how scientists reconstruct the past. It's easy to imagine the story ends when the sea drained away and only rocks remain. But in truth, research continues, powered by technology and human curiosity. Scientists seeking to understand prehistoric oceans do more than collect fossils. They analyze isotopes preserved in shells and stone, mapping the chemistry of seawater millions of years old. Strontium and oxygen isotopes, trapped in ancient limestone, reveal temperatures of bygone currents and changes in global climate that helped raise and lower sea levels. Researchers drill deep into Kansas's bedrock to extract sediment cores, thin cylinders of layered earth that act as time machines. Each core displays a history of marine clays, ancient storm debris, volcanic ash, and even microscopic plankton. By reading this geological library, scientists reconstruct not just a local seaway, but the massive changes that once swept across the entire continent. Other teams employ high-resolution techniques, such as interferometric synthetic aperture radar, to measure subtle changes in land elevation, or to detect geological structures buried far below the surface. Each new sample adds a puzzle piece to the complex picture of ancient North America, a world in which coastlines ebbed and flowed repeatedly over millions of years. Geologists also search for markers of catastrophic events in sediment, sudden layers of debris or chemical changes that indicate ancient storms, meteor impacts, or underwater mudslides. These event horizons record not only slow and steady processes, but dramatic episodes that shaped ancient life and landscape. In rare cases, chemical signatures in fossilized shells and bones have revealed traces of deep earth processes or shifts in ancient oxygen levels, giving us a glimpse into the deep history of our planet. Such discoveries aren't accidents. They are the result of careful, methodical work, a slow unearthing not just of rocks, but of narratives formed over eons. If everything we thought we knew about Kansas could be rewritten by fossils and stone, what mysteries might future technology help us unlock beneath our own feet? A glimpse into the extreme, modern deep-sea ecosystems and fossil parallels. For every fossil unearthed from Kansas's ancient seabed, dozens more are being found today in unexpected, extreme environments around the globe, proving that life can adapt and flourish where we least expect it. For instance, scientists have discovered, in the brackish waters of the world's largest alluvial island, an organism previously unknown, a modern reminder that much of life remains undiscovered. Elsewhere, deep-sea explorers have found astonishing ecosystems thriving near hydrothermal vents on the ocean floor, where chemosynthetic communities live without sunlight, nourished by chemical energy flowing from Earth's interior. Bizarre creatures, blind shrimp, giant tube worms, methane-consuming bacteria, offer parallels to the environments fossilized in ancient seaways like Kansas. What constitutes a healthy marine ecosystem? The discovery of new species, in both fossil and living populations, reveals a key: biodiversity, complexity, and a delicate balance between predator and prey. Yet the fossil record also reveals what happens when that balance collapses. Species disappear, ecosystems are buried, and entire worlds wink out, preserved only in stone. Kansas's sediments stand as evidence. Within their layers lie not just records of life, but markers of extinction, snapshots of upheaval preserved for eternity. Here, a shift in climate. There, a sudden influx of sediment. Elsewhere, layers telling of events that suffocated entire sea-dwelling communities. Remember, scientists estimate less than 1% of all species that ever existed have left behind any fossil evidence. For every crinoid disc or ammonite shell found in Kansas chalk, countless organisms are lost without a trace. Marine researchers continue to drill into modern seabeds, sometimes using oil rigs, sometimes deploying submersibles. Off Cape Cod, scientists even discovered vast reserves of fresh water buried beneath the seafloor, a find that brings fresh insight sometimes into how ancient coastlines might have shifted and what the subsurface might still conceal. Such work highlights how much more waits to be uncovered in both the present and the deep past. As scientists probe ever deeper into both lost worlds and today's hidden ecosystems, they push the boundaries of our understanding about the diversity and resilience of life on Earth. A land without ocean when the seaway vanished. If Kansas was once the floor of a mighty ocean, we must ask, what happened when the waters disappeared? Over millions of years, the western interior seaway shrank as tectonic plates uplifted and the land rose. Mountain chains grew to the west, climate shifted, and drainage patterns changed. Rivers carved their way across a landscape that was drying year by year. The sea gradually retreated, its final remnants vanishing north and south until only isolated bayous and shallow lagoons remained. Then those too disappeared. Prairie grasses and forests slowly spread across the once submerged land. But the sea's departure was anything but quiet. As the waters waned, some marine species kept pace with the receding tides, while others, trapped in shrinking lagoons, faced abrupt extinction. The fossil record in Kansas traces this decline, showing reduced diversity, shifting salinity, and sediments marked by cycles of drought, flooding, and abrupt environmental change. Chalk and limestone, formed in the quiet depths, rose above the water and weathered under wind and rain. Ancient rivers etched canyons into the former seafloor, revealing layer upon layer of history. Each thunderstorm, each winter freeze, exposed new fossils for future generations to find, scattering the evidence of that long-lost world across the Kansas prairie. Remarkably, some of the fertility for which Kansas farms are renowned today can be traced to the mineral richness inherited from the ancient sea, nutrients, salts, and calcium left as a legacy for modern agriculture. But even as the ocean vanished, it left behind clues: seashells, chalk cliffs, fossilized bones, an unbroken chain linking us to distant epochs and reminding us how much landscapes can change. The modern implications, where the evidence points. Why does it matter that an ocean once covered Kansas? For many, the idea borders on science fiction, almost unimaginable. But for scientists, the ancient seaway is more than a historical detail. It's a reminder that our planet's most familiar places can change with astonishing speed and scale. When researchers flock to the Badlands and outcrops of western Kansas, they aren't just seeking curiosities or adding to museum collections. They are searching for a blueprint, hoping to understand how entire ecosystems emerge, thrive, face hardship, and sometimes vanish. The Kansas fossil record isn't simply a catalog of extinct animals. It is a warning, preserved in stone, that Earth's environments are in constant flux. The direct evidence, seashell-crowded limestone, thick chalk deposits, rich beds of crinoid fossils, does more than prove the existence of a vanished sea. It illustrates how continents can be drastically reshaped and how places that today seem stable and permanent once sat at the heart of global upheaval. Elsewhere, researchers have found geological evidence that even distant planets have had vast seas. Mars, for example, shows roots of ancient rivers and signs that an ocean may have covered a third of its surface long ago. If water can transform a barren world, what does that tell us about our own Earth, where change is ever present and new discoveries continue to revise the story? In every fossil, core sample, and layer of chalk, evidence waits for those willing to look. And as scientists continue to dig, scan, and question, they are forced to wonder, what else do we only think we know? How much of our understanding of time, geography, and life is yet incomplete? In Kansas, the past is not just buried, it speaks through stone. If the ocean could come and go, leaving only fossils and chalk behind, what might still lie ahead for landscapes we take for granted? Let us know your thoughts below. Do you believe Kansas's buried seas still conceal undiscovered secrets? Do these ancient proofs change how we see today's continents and the future of our world? Don't forget to like and subscribe. As long as Earth continues to reveal its astonishing mysteries, we'll be here to uncover every revelation, no matter how deep the story goes.